There's supposed to be nothing in the week 9 lab.
There isn't supposed to be. So we're going to work on your next, oh no, hold on. There should be something in the week 9 lab. Go and fix that. So while I'm doing that, what we're going to start with today is some people wanted to look at some of the practice problems from last week. So we're actually going to start with those. So I'm going to talk about those first. And then we're going to talk about the next mini project. And then after the mini project, we'll work on, we talk through the mini project, then we're going to work on this week's lab. So let me go in. I'll fix that lab here in just a minute. It'll take me just a moment. So, but first I want to look at some of those practice problems from last week. So let's start there. All right. All right. Can everybody see my screen? All right, perfect. So we're going to look at some of the practice exercises. So we're going to start out with the practice exercises from 8.2, and we're going to talk about exercise 3 first. So this one is very similar to the exercise on page 2 from the module 8.2 notes. So I'm having some computer trouble here, not wanting to work for me. All right. So here is the question. And so the first thing I want to do is I just want to point out a couple things on this particular question. So we've got 2 different models. I did notice a typo in the model. So if you look on yours, there was a subscript 5 here and a subscript 6 here. Obviously that can't be right because we're not going to have the beta 5. That was a typo. So I've changed those to the 6 and 7 here. All right, so we have 2 different models. Notice that we've got our interaction model, and we call it the interaction model because it has the interaction terms. And then we have our first order model. And so here is our first order model. And notice that the first order model only has those main effects. So we could also call this the main effects model. And one thing to notice, when we look at the interaction model, notice that the interaction model, we could look at it as 2 different pieces. And this first piece is the same as the model that we have here. Would everybody agree with that? And let me, except for some reason I'm not seeing everybody. There we go. Okay. All right. So the first thing we're going to do is perform the model utility test at the 5% significance level for the full model. So here is what we call the full model. So if you remember in the note set, we talked about what's called that nested F test. And so when we look at the nested F test, we have what's called a full model and a reduced model. So for this example, this piece is going to be the full model, and the second one is going to be the reduced. So we're going to perform the model utility test for this model. Now, in order to do that, we need our output. So here, you'll notice on the next page, we have the full model output. And to do the model utility test, we need the F-test statistic and the p-value. And so that's what we have right here. And so that's the F-test statistic and the p-value that you would use for part A. And that's going to be very similar to the model utility test that we've seen before. Now, one thing to notice, as we can see here, looking at that F and that p-value, this test was not significant. So in practice, if the model utility test is not significant, we would just stop here. We wouldn't go any further. We would say, hey, model's not useful, we're not going to use it. But for the sake of illustration, I did ask you to go ahead and conduct a test to determine whether the interaction terms are necessary. And so notice the interaction terms are going to be all those terms from beta 4 to beta 7. So in other words, we have 4 different parameters, and we're going to test to see whether or not we have evidence that those parameters are non-zero. So in order to do that, we're actually going to need this formula right here. So this is that nested F test that we saw in the notes. So to fill in this formula, we're going to go back to our output, and notice that this formula is going to use some values from the reduced and some models from the complete or full model. So here are the highlighted pieces we need. So from the full model, we have the SSE for the full model and the MSE for the full model. That's each of these in blue. And then if we go to the reduced model, there's going to be our SSE for the reduced model. So then we can come up here, and then your next step is you would fill in these values. You would calculate your F. And then once you get your F, we could use R to find the p-value. And so I've got the code there about how we would do that. And then this hypothesis test is just like the other ones that we've seen before. So I kind of want to stop here, get everybody's screen to where I can see everybody now. Are there any questions on this particular problem? Does everybody feel like they could go through and work this problem now?
So for the value of number of betas tested, that would be 4.
Yes, exactly.
Okay.
It's gonna be beta 4, 5, 6, and 7. That's exactly right.
Okay.
So just for clarification then on that, because that was like where my main question was I was confused about that. It's anything that's not part of the first order model, correct? So like, what is the best way to understand like how many we should be using?
Yeah, so it's really, you can just do that visual comparison between the two. So notice how in the full model, I broke it into the 2 pieces. So since these pieces are the same, this second piece, these are all the ones that differ. And notice that there's 4 betas in here.
Gotcha. Okay, perfect.
So when you set up, let me move this up just a little bit. When you set up that hypothesis test, you're going to have your null and your alternative. So under the null, you're going to have all of those betas equal to 0.
Okay. Okay.
And then under the alternative, you know, at least one of them is non-zero.
Non-zero. Okay. Perfect. Thank you.
So when you're reporting the degrees of freedom, will your, like in this case, your K, so like your N is gonna be what, 4? And then your K.
So for this one, N's 200 because we had 200 subjects.
Or rather 200, and then K is gonna be 200 minus 4 in this case.
So K is always the number of betas excluding the intercept in the full model. So in this case, in the full model, notice that we have 7 betas. So in this case, K is equal to 7.
7. Okay.
So when you do your F test in your numerator degrees of freedom or your first degrees of freedom are going to be equal to the 4, since we have 4 betas in the hypothesis test. And then in the denominator, those degrees of freedom are equal to N minus K plus 1. So in this case, we had 200 subjects. Our full model has 7 betas. So we're going to have 192 degrees of freedom in the denominator.
Okay. All right, so I'll have to fix that in the other one.
All right. So does everybody feel good with this one? You all ready for the next one?
Can I just ask a quick question in terms of so I understand why it's 200, but why is it then on, when you get the output, the corrected total is 199? Like, why do you use one versus the other?
Yeah. So what this is accounting for, so this is in the ANOVA table. So in the ANOVA table here, you actually always have N minus 1.
Oh, that's right.
Yeah, I was trying to think of the best way to describe that. What that has to do with is, trying to think of the best way to describe that. It's essentially, if you had in there, you really don't have that many pieces, I want to say like independent pieces of information. It's really, if you had N minus 1 pieces of the information, you can always get the nth one. Is kind of one way to think about it. So it's always
that makes
minus
sense.
1 there.
Okay, thank you.
You're welcome.
I guess I'll say this too. Like I was reading about this in another place. So let's say if we were to take the average of say 1, 2, and 3, right? The average of that is was it 6 divided by 3, which is 2, right? So in a sense, you don't even need the 3 to tell you that you have 2 degrees of freedom. So I think that's why it's always one fewer than what your what your average is.
Yep, nope, that's exactly right. So just like you said, if I had the numbers 1, 2, and 3, and I told you that the average was equal to 2, if I got rid of the number 1, you could still tell me what number was supposed to be in that place. Whereas if I got rid of the number 2, you couldn't tell me what to, it's not a unique solution for those 2. So that's exactly why you've got the N minus 1 there.
For anybody that's curious, it's called Bessel's correction.
I did not know that. I didn't know what the name of it was. All right, so how do you all feel? Can we move on from this one? All right, so next we're gonna hop down to the 8.3 practice problems. So we've got these here. And so the two that people asked about were the exercise 2 and exercise 3. So we're gonna start out with exercise 2. So exercise 2 is application of the definitions on pages 5, 6, and 9. So what I've done here is I've written out the different pieces and then I put the corresponding definition so you can see that next to it while we look at these. So the first thing to notice here is we do have 3 different predictor variables. The first 2 are going to be quantitative. And the third one is categorical. All right. So the first part says, write the 3 possible simple linear regression models. Well, remember when we work with a simple linear regression model, that's the same as the first order straight line model with a single independent variable. So we've got 3 different variables here, so we could write 3 simple linear regression models. And so for example, the first one would be the expected value of y is equal to beta naught plus beta 1 x1. So that's one potential simple linear regression model we could have. So this is going way back to module 2. I think we started talking about simple linear regression. We could also have the expected value of beta naught plus beta 1 x2. So that's another potential model. And then the third one is the expected value of beta naught plus beta 1 x3. And notice this one here is a little bit different than the simple linear regression models that we've talked about before. So if you didn't include this one, that would be fine, because when we talked about simple linear regression models before, we did talk about them in context of a quantitative predictor. So if you just did those 2, you know, if you just said, well, this one really isn't the same as that, I would have counted that. But we can talk about this as a first order model. So this would be fine as well. For the second order models, these are each with a single quantitative predictor. So our first quantitative predictor is x1. So here we would have the expected value of y is equal to beta naught plus beta 1 x1. And then what makes it a second order term is that we also include beta 1, or probably x1 squared, and then beta 2 is the coefficient. And then the other model that we could write out would be the exact same, but with x2. So
Does
what
this have anything to do with like weighting at all? Like adding a weight to the function, or is that
this is more taking into account the patterns that we could see. So a second order model would take into account if your scatter plot looks like this and there was curvature in your scatter plot. The second order model takes care of that and fits this type of line. Whereas notice if we tried to fit a first order model, that would put a straight line through this, which might not actually be a good fit. So in other words, it would be missing part of, you know, the patterns that the data follows, whereas a second order model can actually pick up that curvature. And then same thing, we could look at a third order model. And so looking at our first quantitative variable, we would have the following. Sorry, handwriting is not that great on here. But really the new part here is this piece right here. So that's our third order term, or the cubic term. And again, what these different order terms allow us to do is they allow us to pick up different patterns in the data. So for example, if you had data that looked like this, a third order term could pick up that pattern. So that's what this is allowing us to do. Now in practice, it is rare to use third order terms unless you're talking about time series, and in which case you're not actually going to use the third order term anyways. You're probably going to use like a sine or a cosine, something like that. I mean, and there's nothing to say we couldn't go up to 4th, 5th, 6th, 7th order terms. It's just in practice, we generally don't. So you're usually going to see the most often are the first order and the quadratic terms are the ones you're going to see the most often. And again, because the reason for that is, you know, the first order, you're really looking at straight lines. Quadratic allows you to add in curvature. So, and then finally, the last one is the interaction model. And so this is the interaction model for heart and age. These were our two quantitative variables. So here, we're going to have our intercept. You're going to have your main effects for the two variables. And then you're going to have the interaction between them. And so that would be your interaction model. All right, questions on these?
Okay, so I'll just openly admit I did nothing that simple. And I have literally no idea what I did. But I think I was confused by it because this like makes sense now that you're explaining it, that that's as simple as you wanted it. But I guess I was trying to like fit all the variables in, but still have the third order. And so then I was like, felt like I was like just putting exponent kind of things on random things. And I didn't know like what belonged actually where. So I think that that's why I was confused when it was like asking for multiple. I was like, multiple of what? So like, for example, for like C, if you were to make like a second one for the second variable, it would be like B3X3 2, correct? Or instead of, I guess that's where I'm confused is like, how do you,
so since it's a whole new, so notice you're writing two possible models. So
yeah.
the whole new model that we're writing, it's fine to just repeat the subscript.
Okay.
So because it's a whole new model.
Yeah.
So you would have this model that's in terms of X2.
Oh.
You say, because I'm saying like these are two completely separate models.
Oh, okay. Got it. Okay. Yeah, I did nothing like that. Perfect. Good to know now.
No. And one thing that I think is really useful about something like this is I think there's a lot of confusion between variable selection and model selection. And we're going to spend some time talking about variable selection, but you know, I think people get confused between the two in the sense of, you know, you're given this data set and there's all of these predictors. And so the question is, which of these predictors is useful? So in other words, that would be variable selection. We're trying to figure out which ones we want to use. But that's only part of the step, because once we figure out what variables we're going to include, we have to figure out how to include them. And so just as, I mean, this simple exercise that we've, well, not simple, but for this, you know, exercise that we've got here, notice I only had 3 different predictors, but I mean, you all end up writing out, what, 6 or 7 different models that use those variables. And there are lots more that we could write out as well. So you can see, just because, even if I tell you to use these 3 variables, there's lots of different models that we could choose, and each of them is going to lead to a different prediction. And so that's why it's important that we not only, you know, conceptually we think about what variables we're going to include, but also how we're going to model those variables. What type of model do we need, you know, for those variables to have our prediction, you know, or to make predictions. And so it's really a 2-step process there. And I think something like this illustrates that, you know, again, it's not just what variables, but it's also a question of what model we use.
I have 2 questions that just because my quasi-mathematical brain is bothering me about them. But like, is the fact that you can essentially write 3 separate models, does that have anything to do with the idea that you could like decompose a complex function into sort of component functions, or is that not even applicable in this case?
In this case, it's not, because this one I'm considering each of these variables to be independent.
Separate.
Yeah, so I really am looking at 3 separate models where each of them looks at a single independent variable. Now, you could talk about, I'm trying to think off the top of my head. I mean, you can't, I'm sure you could relate those two, but not in this specific instance.
Gotcha. And then like, and then just from like math, what's the thing where like, you know, if you have a polynomial equation, this isn't necessarily like the number of, like the k-1 thing. Does that have to do with like the number of roots of a polynomial, or like?
Yeah. So not really. So because when we're talking about polynomial models, we're really just referring to the fact that we are taking things to different powers. Because notice that the terms that we include in the polynomial models, we could have different types of terms. So we might include the interaction, we might only include the quadratic terms. So I don't want to say that that is directly related there, because there are lots of different types of polynomial models. Now, in terms of finding the zeros or the solutions, that does come into play in the actual like mathematics of what's happening behind the scenes, which we're not really going into this in this class. So if you think of like that matrix representation that we looked at earlier, you could get into some of that those mathematics and talk about how we actually find the estimates for the betas, but you know, we're not covering that part.
I'm just thinking back to like algebra and calculus or something. It's like the number of the number of times like a function goes from like concave up to concave down or something, that kind of gives you the idea of like the power, the order of said function. Like I'm just trying to remember what that rule is or something like that. It's a very fragmentary thought. That's why this probably sounds like a bunch of gobbledygook.
No, you're fine. Yeah, I mean, as far as like what we're doing here, it's not really a direct relationship to this class. I mean, again, if we looked into the, you know, the mathematics that are behind this, we could find relationships, but it's not like a direct, it would be like a tangential thing at this point, if that makes sense.
The other trouble with that too is that assumes that you have a priori knowledge about what's going on with the function. You know, like when Amanda drew out those scatter plots and then drew the first, second order lines on them, that was just from eyeballing, which is a pretty common way to do it actually. And now, of course, Ankur, you do machine learning stuff. A lot of it is by using training data and then comparing it to how it fits with test data to decide the order of the polynomial, because in some fields you get up to like 9th or 10th order. And then you often also have log portions as well. And so at that point, it's more machine learning, because you look at it and it just looks like, to coin your term, a bunch of gobbledygook.
Can I ask another kind of dumb question? I guess maybe this is something I should have caught on by now, but
no such thing as a dumb question, Elizabeth. Never.
Right, and I really do that.
Okay, so like I'll just be honest, like I was like creating new like NX4 X, like I was doing all that because I was very confused. So like in which is it in the situations to where it just tells you like, so for like surgical services and medical services, like that was a type of service. So is the time that you like create a new variable kind of sorts is when they just only give you those different like high, medium, low or whatever? Like when is it that we like make our own versus we just use the one? Does that make sense?
No, it does. So in this case, we can use them as written because service only has 2 levels. So remember, any categorical variables, any categorical variable, the number of dummy variables you're going to need is always the number of levels minus 1. So in this case, since service only has 2 levels, we just need the single variable. Now, let's say there had been, you know, a third service that was listed, then you're right. We would need to break that down into 2 dummy variables. But in this case, since there are only 2 levels to service, we don't actually have to do that.
Okay. Yes, that makes sense now that you say that. Okay, thank you.
You're welcome.
I had like completely like understood the dummy variables and how that happened, but I had completely removed that from this kind of stuff. So okay, thank you.
No, it all fits together. Sorry, I was trying to get, I don't know what happened to the lab, and so that's why I was listening, but I'm also trying to fix the lab. I'm not sure what happened there, so I'm fixing that as we speak, I think. Sorry. Okay, so any more questions on this one? Does everybody feel like they could write out these models now? All right, so let's look at one more. We've got, this one was exercise 3. We're back with that ICU data set. Now this time we're only going to look at 2 quantitative variables. They are heart rate and age. And so the very first thing we have to do is write a complete second order model. So this is going to be similar to the ones we just looked at. So we're going to apply this definition of the complete second order model, and that's going to give us our model. And notice that this definition, this complete second order model with 2 independent variables, this is actually exactly what we have. So you could actually just copy this piece right here, and that is your complete second order model. All right. So next, based on the output given below, find the least squares prediction equation. So first, looking here, notice that we've got, the intercept and then our 5 coefficients. So if we go down to our output, I've highlighted this piece in green. So notice here, we've got, you know what I just realized? Hold on just a second. Huh. Okay. Right. Yep. So you all can't actually answer that question. That was a trick question. I just realized I gave you the wrong piece of output. So yeah, nope, can't answer that question. So let's just take off part B. So that's probably why you all were confused. So I apologize for that. Yeah, so I needed to, in SAS, I think I didn't include the slash solution. And so SAS will generally give us those estimates, but I just realized the piece of output that I have included here does not give you those estimates. So you can't actually answer part B. So I'm gonna just nix that off. Don't worry about those points. You'll just get the 5 points. But we can do part C, which is the model statistically useful? That's that model utility test. We've done lots and lots of these. And so this is that blue box right here. And so that's that model utility test that you're used to. So again, that one is 100% my fault. So yes, so ignoring part B, how do you all feel about part A and part C? Does everybody feel like they can do parts A and part C? All right, perfect then. All right, so what we're gonna do now is I'm gonna stop sharing this. Are there any other questions about the practice exercises that you all would like to look at? All right, so if there are not, go ahead and go into Canvas, take a few minutes, pull up your next mini project and have a look at that.
The mini project 2, when you click into it, it says this assignment is the first mini project.
I'm thinking.
I think it's the right PDF. It's just in the little Canvas blurb when you go into the assignment.
Weird. I think some of the stuff I did in Canvas did not save, is what I'm now thinking. I'm going to fix that right now, though.
Yeah, it's the right PDF.
Is it? Okay, perfect then.
Yeah. It's just the other part.
Yeah, good. I was scared because I'm still trying to fix the lab right now, and so that's good. That's good.
I feel like the note you put in there, note this project is not intended to suggest that this is the best way to analyze this data set. As we progress in the course and learn new methods, we will apply the methods to the data set. Should be like applied to all math, stats, any of that stuff.
It's really true. It's so true. Because I mean, yeah, especially like when you're starting at some of like those beginner, techniques in practice, we hardly ever do that. Oh, Lauren asked a great question in the chat. Yes, please, those practice problems, if you want to resubmit those, please feel free to do that. If you want to do that maybe by like tomorrow evening, that is perfectly fine. I'll just let Shalita know, to hold off on grading those. So yes, please, if you want to resubmit those, please feel free to do that. All right, so let me now go. All right, so first of all, just looking at the mini project, has everybody had a chance to kind of glance through it? Does anybody want some more time? Okay, so you're gonna notice it's somewhat similar to what you did last time. So I don't want you to reinvent the wheel. The pieces that you can pull from the last mini project do, because I mean, you're still writing a very similar document. It's just now our methods that we use are gonna be slightly different. So there's gonna be parts that need to be updated. So this one, I'm gonna have you look at some multiple regression. And so first of all, you have to choose 3 quantitative predictor variables. So I'm gonna leave this up to you all. That choice is gonna be up to you. You've got lots of choices in that data set. So the first thing I'd like you to do is to fit a full interaction model, including the 2- and 3-way interactions. Now, with that being said, if you choose 3 quantitative variables and you fit that model, including the 2- and the 3-way interactions, and your overall model utility test comes up as non-significant, I would consider looking at another set of 3 variables, just because that no matter, even if you go the 2-way or the 3, way, or part the 3 main effects, probably not going to be useful. So I would try to find one where that full interaction model is significant. You're also going to look at the model with the 2-way interactions and the model with only the main effects. So then from there, what I want you to do is, after you fit all 3 of those models, I want you to determine which model is the best and give some justification on the model you decide to use. And so this really is a balancing act. The first thing you're going to want to do is, again, look at those model utility tests. And then you're going to want to do things like test, are the interactions actually necessary? So it might be that you fit that full interaction model, including the 2- and 3-way interactions. Your model utility test is significant. You go on. Now to test those 2-way interactions, you are going to have to do that partial F test. You do that and you find out the interactions aren't significant, so you decide to go on to the main effects model. So these are some things that I want you to consider, as you're comparing your models. How are you going to compare them? And the other thing that I want you to consider is to look at that R² value. So if you'll remember, we had that one example where we looked at the higher order terms. And so we had a model with a single predictor where we looked at the first order model, we looked at it with the square term, we looked at it with the cubic. And what we saw was, even with the cubic, that overall model was significant. But if we looked at R² and we looked at the gains that we were getting with that model, it was really minimal. So that's something that I want you to consider, because we don't just want to always blindly use our hypothesis test. We also want to think of the complexity of our model. Having a more complex model, is it really helping us? And so that's something I want you to consider. So from there, again, similar to what you did before, you're going to write up a method section and a results section. I do want you to make sure in your methods you talk about how are you going to compare these models? What things are you using to decide which one is going to be the best? And then in your results section. I've got the rubric there for you. So something different I did with this rubric to entice you all to bring drafts to class next week. You will notice that the draft is part of the grading rubric, and there are points associated with the draft. So you just have to have a 2-page draft next Tuesday when we meet. Other than the lab we're going to do today, there are no other assignments for this week. So this is your focus for this class. There's no videos, there's no practice problems. Lost my train of thought, sorry. You have to have that 2-page draft. I'm not going to grade that draft in terms of quality. I just want to see that you have a draft to share with your peers. Now, that 11 points is just for whether or not you submit a draft on Monday. If something comes up, you can't come to class, or probably submit it on Tuesday before class. If you can't come to class on Tuesday, I'm not going to penalize you for that, you know, because I realize attendance is not part of the class, so you're not going to get penalized if you don't come to class and share your drafts with one another. You'll only get penalized if you don't turn in that 2-page draft by the start of class. So my goal is for next class, what we'll do is everybody will turn in their draft. I'll pair you up. I'll give you some guidelines, and that way you can give each other feedback on your drafts. And then during class time, you can go ahead and make those corrections. So by the end of class next week, your final, you know, paper will be ready to submit is the goal. So I realize that's a short turnaround time in terms of when you turn in the draft to when you turn the final project. But the idea is we make all those corrections during class. By the end of class next Tuesday, paper's ready to turn in. All right, so any questions on that?
Do you want us to like physically,
Go ahead.
oh, sorry.
No, go ahead.
Like physically submit the assignment on Canvas just to that same assignment, or just bring it with us to class?
So do submit it so that way I can see it submitted on time. And you'll notice in the mini project too, if you go into, I think it's in the module, but let me double check here really quick. I made a space.
It's in the module before you go into the assignment. There's a click here to submit the draft.
Oh, I see that now. Okay, perfect.
So you
Thank
can
you.
just
Sorry, I hadn't
you'll
caught that.
see that when you do that, it's going to show that it's a 0-point assignment. And the reason for that is it's 0 there because the points are on the actual assignment.
Perfect. Okay, perfect. I had totally overlooked that. Thank you.
You're welcome. Manasa, did you have a question?
That was my exact same question as well.
Perfect then. So yep, so you'll just submit that there. And again, I don't want you to feel like it has to be perfect. I think it is so valuable to see other people's work because they might have done something that you're like, oh, you know, I should really include that. What a great way to explain that. Or it might be that you thought something that you wrote was very clear. And then the other person will say, well, this is what my takeaway was from your paper. And then you can be like, oh, you know, I need to polish this up a bit. So I don't expect your drafts to be, you know, like super polished, but I do expect them to be, you know, complete enough that you can get feedback from others and then work on them during that time. And of course, that's a time that you can ask me questions as well. If you're, you know, if you're stuck on something, you're like, yeah, I'm not really sure the best way to word this or to present this information, and I can help you during that time as well. All right, so if there are no other questions, if you all will give me just a second, I'm going to get that lab posted so we can look at that.
Dr. Ellis, is there like within R, is there a better way? Like I just found an answer for like 2-way interactions. Is there like a more sort of elegant way in code to like specify all the interactions instead of having to like manually list this out?
That way I'll have the 3-way, the one that you sent me, Stack Overflow, because all it's doing is mathematically multiplying them together.
Yep, so because I'm going to guess you're just using the star.
This one you can like specify which ones you want to interact. So it's just easier. Because like now, like in my head, I'm thinking about this. Like, what if you were doing this for like 50 or 60? Like, there's no way you could.
Yeah, I mean, well, you still have to tell R what the variables are.
Sure, but it'd be a lot easier. It would be a lot easier to write those to like. Because it's easy enough if you have a data frame to extract out the names of like all of the variable names. It's easy enough to do that in code, and then to get all of the possible interactions. It would just.
Yeah, but with that being said, I mean, this kind of goes back to the argument though. We do want to consider model complexity. I'm never going to put a 50-way interaction in a model.
Oh.
That lab should be up now. If you all do not see that, please let me know. But I think it should be up now. Fingers crossed. And I think I got all the necessary data sets, but if I'm missing one, let me know. So before you all get started in the lab, one thing that I did want to point out is when you get to the SAS code, one of the things that we've been doing is we've used ProcGLM quite a bit, but when it comes to that nested f-test, that nested f-test is a lot harder to do in ProcGLM. You have to use what are called contrast. I don't know if anybody's used contrast before in SAS. So you have to use contrast, and what contrast relate to is that idea of comparing means. So remember when we looked at categorical variables and we saw how we could relate the beta coefficients back to means. In other words, we related betas to mu's. Contrast kind of going with that idea, and we're not covering that in this course. So when we get to the nested f-test, you're going to notice in SAS that I actually use a proc-reg procedure as well. The nested f-test is a lot easier to do in proc-reg than it is in GLM, just in terms of, now if you're used to contrast, then of course the proc-GLM is just as easy. But in order to do that, what you're going to see is I actually have to do a little bit of data manipulation to get my different pieces of my model. So when you get to that step, if you have any questions, let me know. I've put a little note in there of why we're going to do this, but what we have to do is in our actual data set, we have to construct the dummy variables and the interaction terms, and we add them in as columns in the data set. And again, the reason we're doing this is so that we can use proc-reg to get that nested f-test, because we can't do the same thing in proc-GLM. Proc-GLM, you have to use contrast statements. So when you get to that step, it starts on page 5. That is why I've done it that way, but know that you could do it in ProcGLM. It's just we haven't talked about the necessary background to do it in ProcGLM. All right, I'm gonna sit back. As you all have questions with the lab, let me know. And yeah, and if I, again, I think I got all the data sets in there, but if I'm missing one, just let me know.
Just because I have to inject some levity into the proceedings, I opened up my R, and for one of the labs, I think it was lab 7, where we're looking at the multiple linear regression for categorical predictors. I think there was one of the steps where you wanted us to write the improper model, where you're trying to use region as a number. I literally have a comment that says bad juju.
I don't think any of us need any bad juju right now.
And then the one below that is like, okay, proper model.
I just realized if you look on page 2, remember that typo that I had in the practice problems where those betas were misnumbered? It's on the lab as well. So I'll fix that and upload a new one. But you're probably going to see that in both the R practice problems and the SAS. So for example, on page 2 and step 4, you'll see there's 2 beta 5s and a beta 6. It should be beta 5, 6, 7. So I'll get that corrected.
For the degrees of freedom, it gives us, for the ANOVA statement in step 3 of R, here it has the degrees of freedom. It looks like listed as 8 and 10, but when I look back in my notes, I have degrees of freedom of 2 and 8. So I was just wondering why those would be different. You're on mute though.
I'll make it a whole class one day without. All right, so here we're looking at the burn rate. Okay, so let me go back to those module 2 notes. Give me just a second here, because they should match.
And all the other numbers match, which is why I thought it was kind of odd, but
It could
maybe
have
I'm just reading it wrong.
I'm getting to those.
Maybe I wrote my notes wrong. That's very possible as well.
This is an 8-2, right?
Yes.
And we're looking at that fuel and brake example. This is for the nested models. So it should be 2 in the numerator, and that's what R is giving you, right? And then
2 in the, well, what I'm reading, maybe I'm reading it wrong here in R, but it looks like the 8 is the numerator and 10 is the denominator. Maybe I'm reading this wrong.
And oh, hold on. Which ANOVA are you looking at? Because you're looking at the output from the ANOVA?
Yes.
All right. Give me just a second. Let me actually run this on mine.
Okay.
So that I make sure we're looking at the same output.
Okay. Because I checked everything for the full and the reduced, and all of that looked the same based on the output that I had.
There we go. I couldn't find my code there for a minute. All right, so let's run this. All right. So we get the 8, and then we'll come back to 4. So we have 14 observations, correct?
Yes, correct.
So, and then in our full model, we have 1, 2, we have 5. That's 1. So we should end up with 8 in the denominator and 2 in the numerator.
Mm-hmm.
Okay, and that's what we had in the notes, correct?
Correct, yes, which that totally makes sense.
I see what's going on. So the way that R outputs this is a little funny.
Okay.
So where you actually want to look at is that horizontal line that starts with the 2. And do you see where it has degrees of freedom 10 next to it?
Uh-huh.
And then it's got a -2 degrees of freedom. And then we go over and we've got our F and our P value.
Correct, yeah.
So this output, I'll be honest with you, I usually, when I do my degrees of freedom, I usually just do them, in my head, just to kind of do the sanity check. But what is happening here, if I'm not mistaken, is we've got that -2.
Okay.
So that's actually telling you your numerator, and then you take the 2 away from the 10 to get the 8, as I think what is happening there.
Okay. Okay.
Or is it actually, I'll make sure we're doing this right. 2, yeah, I think it's the way it reports its degrees of freedom is funny here in that comparison.
Okay.
So for this, I would just do the degrees of freedom on my own and not worry about what they've got there. But that F-test and the p-value should be the same.
Should be the same. Okay, perfect. Yeah, and that was the same. That's why I was like very confused.
Yeah, okay. So it's what it's doing is that -2, it's telling you there are two parameters different between the two. So that's how we know that the 2 is going to be in the numerator.
Okay.
So that's what's happening there. So
okay,
it reports in kind of a different way than we're used
to. Different way. Okay, no worries. Thank you for checking on that.
You're welcome.
R is mad at me.
What'd it do?
It did this. Here. Give me this warning.
So this one, so I think the problem is when you run that heart rate times age times systolic, or actually
that would be the through interaction, right?
Yeah, but notice you've also got this heart rate plus age plus systolic squared.
Yeah, because aren't those the two-way interactions?
Yeah, but that's not how those would run. So really what I would do here is instead of
that should be service.
Oh yeah, that's yes.
That should be this. That. There we go. Now it's happy.
The other way you can do is you can make it do all of the interactions by using
yeah, that's what this part is for all the two ways.
No, so what I was meaning is, I thought we did that before. I'm trying to remember the syntax. I think it's if you use the vertical bar in between the three. I get confused between the SAS and the art syntax. Try doing a different line down, do like FICU2. And do LM, yeah, do that. But now in between your three variable names, do a vertical bar.
Just like this.
Try that for me. Okay. Give it instead of the vertical. Oh.
Yeah.
Okay, so it won't let you do that. Try just putting the star in between the three, and I think it'll include the lower terms for you automatically. Now look at FICU2. Like do your summary of it. So see your summary for your FICU2, see it automatically includes all those lower order terms for you. So you don't actually have to manually put those in. Whereas if you go up to your FICU, it runs into some trouble because it thinks that you've got some of those terms in there twice. See, like where it's got as factor, service, surgical. Yeah.
Hold on. Just because this is making my head hurt.
So one way to think about this is if we include higher order terms in a model, we always include the lower order terms as well. So that's why R does this. So if you specify the highest order term, which is that three-way interaction, it automatically knows the order terms.
So that really which should be quite simply is just
Yep, exactly.
okay. So that makes sense. It's two-way, and then three-way.
I might be the only one, but I'm hearing hella reverb and honker.
Yeah, it's feedback.
Yeah, same.
Here, hold on. Is this any better?
Yes.
Okay, cool. But again, yeah, two-way one, two-way two, two-way three, and then this is the three-way interaction.
Exactly.
Okay, that's a hell of a lot easier in terms of code writing.
And
So
again, it's because anytime you've got the higher order term, so that three-way interaction, we automatically include all the lower order terms. So that's why R knows, and SAS will do the same thing. If you include that higher order, it knows, hey, we're going to need all these lower order terms in there as well.
Okay, so then that makes it, so then that just makes it really kind of like then it would be very, very easy to do a more complicated model, because then you just have to specify just one time specify the most complicated thing that you would want.
Yes.
The trouble is that it's going to comp out all that stuff, and so like you're going to bog down really, really bloody quick. Like your 38, your example from advanced epi with 38 factors, you're going to end up with I don't even know what 38 squared is, something like 9,000 roughly polynomials.
Yep, that's the problem, because so what it's doing is it's creating what we would call it's like a complete interaction model, I guess we could call it. It's an interaction model with all the possible interactions. So it's including all of the possible terms. So if you have a lot of variables, that can get unwieldy really quick, because you're just going to have tons and tons and tons of terms. Whereas here with 3 variables, it's not so bad. But like Finn just said, if you had 38 variables, it would just become completely unmanageable. And in all honesty, with 38, you're probably not going to have enough data for that to be able to fit that. I don't know how big your data set was for that. But so that's really where variable selection comes into play. Can we parse down your variables some first, find what the most important variables are, and then start looking at what model we should use for those variables?
That's like in the machine learning parlance, that's dimensionality reduction, right? Or like feature selection.
I think so. I'm not familiar with the term.
Feature selection is that's when you pick the variables you want to go into your model to sort of, you pick the most useful ones.
And I'm going to guess, and so by most useful ones, I do want to be careful, because when we say most useful, we do want to determine that based on the data. So the data, we're not going to decide which ones are the most useful. We're going to let the data help us, and the data is going to tell us which ones are the most useful. Does that make sense? And I'm guessing machine learning does the same thing. But
yeah.
It's not just, the researcher tells me which are the most important. We let the data tell us which ones are the most important. And we're going to do that here. It's just a couple weeks away. we're going to spend a whole week where we look at variable selection and some different methods for variable selection. And eventually, I think what I'm going to have you all do is you've got this nice big data set here with all of these variables. You know, you all at some point will perform variable selection and see it, you know, see out of all these variables, can we figure out which ones are most likely to help us? And if you'll notice, that was actually one of the goals of this data set when it was initially posted, was that very question. What predictors are useful here? And in terms of, you know, if we think of health analytics and we're talking about population data, you know, one of the things that you all are likely to end up with when it comes to analysis are these really large secondary sources of data where you've just got, you know, massive amounts of variables and massive amounts of variables. And the real question is, can you do something useful for it? Now, the methods that we've been looking at right now, quite honestly, are probably too simplistic for that, but they are on the way to be able to do something with that, if that makes sense. These are kind of the walk or crawl before you walk or even before you run in terms of that analysis, but understanding some of these fundamentals and some of these ideas in terms of, you know, it really is important how we code our variables. It's important that we think about how our variables interact with one another, what order the terms should be, what variables should be included. These are all things to consider if we want to make predictions about what's happening based on different variables. Oh, I might need to add that in, Lauren. Let me take a look there.
Yeah, it's not up there. Ankar, to further answer your thing about dimensionality reduction, you don't usually do that manually either. What you do is, since the reason it's called dimensionality, right, is it's just like turning a square into a cube. Every new variable multiplicatively increases the complexity. And so what you do is, like, if you had 38 variables and you're wanting to reduce down to a dimensional space of 36, you'd run all possible 36 combinations, and then you'd see where things were within some sort of threshold limit, or you'd just take the two ones that are the most similar, and you're looking for things like systolic and diastolic heart rates, say, that are, I'm assuming these are correlated. And so they have a similar effect on everything, and so you can reduce them into just one dimension. And again, the data would still tell you that.
Okay, I'm all sorts of confused / unsure what I have done wrong. For step 4, we're supposed to write our own code for the ICU data. The output that I'm getting does not match up with any of the output I can find anywhere else in our like practice exercise.
Yeah,
so I don't know if,
and I've got the AIDS data
yeah.
set there now.
Okay. Okay, this is what I currently have.
Oh, I see what's wrong, I think. So we're predicting systolic blood pressure. You've got it written as you're predicting heart rate.
Oh, duh. That's it. Thank you.
Fixes, you know?
Okay, let me try that. Yeah, that would make sense.
on the data sets, if it's something that we've already got, we can assume that it's the same data set, right? So like,
Yeah, I
whenever
haven't
you,
seen any of them.
okay, awesome, cool, thank you.
You're welcome. I just posted a link in the chat for anyone that's interested. I got a message about this. It's a data science day, but in particular, Finn, you might be interested in this. Andrew Gelman is one of the speakers, and it looks like it's free. So if nothing else, yeah, to hear Andrew Gelman might be a good thing. And then they also just have different jobs in data science. So if you're interested in learning more about analysis, there's all kinds of stuff there. It looks like they're going to have panelists from academia, government agencies, finance, startup, big techs, insurance, pharmaceuticals. So there's also going to be, a health spin there. So again, if you're interested, have a look at it. It looks like it's free. So even maybe just to see pieces of it.
It actually doesn't look like it's free, but student registration is only $20. So, and it looks like they have resume and CV building and networking on LinkedIn. So it's probably worth the $20 just for the, well, I don't know how much trouble other people have, but I'm terrible at my resume and LinkedIn.
No, I think just in general, the more help you can get with that, the more eyes on those things, the better. I think people really have a tendency, especially with their resumes, building themselves up, have struggled doing that because, we're not supposed to, I think, brag on ourselves, but I think that's a really good place to do that, and having someone else look at that can be really useful.
I think today is the day for strange R errors. I'm getting an error with the plot thing that it says error in plot.new figure margins too large.
Oh, Studio, just make your plot window bigger. And then try to run. If that doesn't work, let me know.
Okay, so I fixed the issue on the first one. Wow, this sunlight is weird,
I can
real
see
weird.
it.
But but I got the first one fixed. That was the issue. But now when I'm looking at the fit reduced model, the numbers aren't matching up to our practice problems, and I cannot figure out what the difference is.
Yeah, you want to pull up the
Yeah.
we'll take a look.
Sorry, I feel like I'm really riding the struggle bus today.
I'm right there with you, so don't.
Maybe I've just looked over it.
You've got that star should be a plus sign between age and heart rate.
Between age and, oh, so they both need to be plus signs for this.
Yeah, because I think
correct.
Double check there because we're just doing the main effects on that reduced model, right? Is that?
I think so.
We just got the X1, X2, X3.
Yeah.
Yep.
Okay, so they all need to be, okay, I thought it was just the last one there.
Yeah, so basically what you can think of the star is doing, that's helping you put the interaction terms and the lower terms in there.
Okay.
Whereas the plus, it's just saying, hey, I just want these individual effects.
Okay, that makes sense. Perfect, thank you.
You're welcome. Let me show you all. Finn actually suggested this, and I think it's a good idea. There's another really useful website. I'm going to take just a minute and show it to you all. It's called StatKey. Let me share this. This website, it was made to go along with an introductory stat book, but it can help you find those p-values for the f-test. So if you look here, it's luck5stat.com. Usually I just Google block 5 or stat key, and it's the first or second thing to come up. I think the first one's actually like a water bottle company, but anyhow. What's nice is if you look here at the theoretical distributions, notice that one of them is the F. Maybe. This will actually draw F distributions for you, and you can get your p-value from this as well as R. So you can put in your 2 different degrees of freedom. So for example, see if I can pull up one that we had already. Let's see here. So if we look at that fuel example that we had, in the numerator we had 2 degrees of freedom, and the denominator we had 8. And you click OK, and it will draw that F distribution. And then if you click on right tail, you can put your test statistic down here. So for that one, it was 8.789, I think. Click OK. And then it will actually give you that p-value up above. So this is an alternative to R, and it's kind of nice because it actually draws that F distribution out if you want something that's a little bit more visual. And again, you'll see that's the exact same p-value you get for the fuel example using R. And I'll put the link to that in the chat.
I don't think this is right. I'm joining Elizabeth and struggling today. Let's see here. This bit.
You do, yeah. Okay, do you mind, let me see your code again for that quadratic model. Define heart rate and heart rate squared and h squared. You actually want to define those outside of the model, kind of like how we did year in the previous one. And the reason for that is R will now see that as a new variable. And then, yeah, now add those in. And then also, I don't think you need the heart rate plus age at the beginning. Go ahead and run that and see. But I think it's redundant because I think the heart rate times age is going to automatically put those terms in.
So let's humor ourselves and take this out. Yeah, it works. But just because it makes more sense to do it this way. I think it just won't be that way.
Yeah. Because it should be the exact same output.
Yeah, it is.
I was gonna, do you have those values up? I was gonna check. Oh, actually, you can't check those values because that's the problem that I messed up. But I believe that.
Yeah, I can get those up for you here.
Well, I was gonna say, those were the ones in the practice problem 8.3 where I asked you all to find find the least squares prediction equation, but I didn't give you the right piece of output. Yes, sorry, correct.
Cool.
Yep, that's okay.
Okay, this might have kind of been what you were just talking about with him, but he wrote his code different. I was confused. So I just figured it might be a redundant question, but I'm like getting a bunch of errors for the same exact step that he was on, I think. And I think maybe I'm just confused about what we're doing in step 5 versus how it translates to step 6.
Yeah.
So if I can share Just some guidance would be nice. So like I guess maybe I'm confused what this here is doing versus what that would do in another data set.
So I'm going to start with just that year. Let me talk about why I did that. So the
Okay.
reason I did that is, so in this particular example, what we're doing is we're using year to predict number of deaths. So year is like 1990, 1991. So notice the X values are pretty large there. Well, I know I'm going to work with a quadratic term. And so what that means is I'm going to be looking at 1,990 squared as a potential value. And so that number is just huge. So what I decided to do instead is, instead of looking at the years in terms like 1990, 1991, I looked at the years since 1990. So all I'm actually doing there is I'm transforming year, instead of it being the actual year, it's just the number of years since 1990. And the reason is so I don't end up with these huge values on my x-axis. So for example, if you look at your plot that you've got there, notice now along the x-axis, we've got the numbers 0 to 25. It makes mathematically, it makes it a lot nicer because I'm not dealing with these huge numbers. But it ends up, if you try to just work with year by itself, you're going to end up with a lot of errors, because what happens, you end up with these really big numbers that are squared or even cubed. So that's what's going on there. And then, so deaths, I'm just pulling the deaths variable from the data set is all I'm doing there, and just naming objects. So that stuff I didn't actually have to do. I just did it because it made it easier. And I know our goal here is to fit a quadratic model. So my model is going to have both year and year squared in it. So third line, what I'm doing is I'm just creating a new object that's equal to the years squared, is all that's doing. So what I would do is, do me a favor, highlight just the word year in that first line.
Here.
2 above it.
Oh, in the first line, I'm sorry.
Oh, you're good. So highlight year and just click run. So let's see what year looks like. So we see that year goes from 0 to 27. And so in other words, this represents the years since 1990. And then do the same thing for the year too. And that way we can compare them side by side. Now see, year 2 is just each of the years squared. So 0 squared and so on. So that's we're essentially looking at those like there are 2 different variables that we're going to include in our model. We've got year and year squared. Next, what we do is we make a scatter plot so we can see what that looks like. So that's pretty.
Purchase that over here.
Scatter plot. See how that scatter plot has got that curve to it? That's what tells me we probably need that second order term. It's not a nice straight line like we've seen before. That curve is telling me, hey, we probably want to include that second order term. So we're going to fit the quadratic model. So notice this time when we fit that quadratic model, we've got deaths and then the tilde, year plus year squared. So just like before, you had heart rate plus age when you had your 2 variables. We're doing the same thing here. It's just now my 2 variables are year and year squared.
And year 2.
And then the summary, just like before, that gives us the summary of our model. So we're going to do the same thing with the ICU. So you're exactly right here. Careful here though. In that line, you're missing the variable you're calling from ICU data. So notice you want to do heart rate squared. So you've got to pull out heart rate from the ICU data set. So you've got to
so I have to put that here.
And make sure, there it is, okay. And then you'll do the same thing for because so that's going to make 2 variables, one with all the heart rate squared and now one with all the ages squared. Now the plot, we're not going to be able to do that as nicely. This is actually a 3-dimensional plot because you've got 2 predictor variables and a single response variable. So we can't make that nice scatter plot that we could before. Now you could plot them individually. So you could look at systolic blood pressure versus age and systolic blood pressure versus heart rate, but I just don't worry about it for this example.
That totally makes sense. Okay, let me fix this.
Perfect.
Yeah, because I kept getting that error and I was like, I don't know why this is erroring, but duh, I never called in anything.
So now when we go to do your model.
So the quadratic model. So is that where you would do like systolic are you pulling in systolic during that? I guess that's what I'm.
Yeah, so there's two different ways you could do this. We
Okay.
could manually pull out systolic and define a new variable. That's one way.
Okay.
Or we could do it just like we did before when we called the ICU data set and just put that data equals ICU at the end.
Oh, okay. Okay.
Now, the only problem is when we do that, let's try it and see if it works. It might get confused because that heart rate 2 isn't part of that data set.
Oh,
So
okay.
it might get confused. It might go look for heart rate 2 in that particular data set and be like, hey, this doesn't exist in this data set. And so in
Okay.
this case, we can just define them all outside.
Okay. Okay. I can never get these two things right. Okay.
You can also just do an equal sign there.
Oh, just like a simple equal sign.
Yep, they'll do the same thing. So in R, that arrow is the same as an equal sign. Well, it's the same 99.9% of the time. A couple
Okay.
rare instances, and I'll be honest with you, like I know that those instances exist, but I don't know that I've ever actually encountered them, if that makes sense.
Okay.
So that's why I put
Good
that
to know.
on there. Typically, yeah, it doesn't matter. It's the same thing. There are different preferences for how people write code. So
Okay.
I write it, I don't typically use it there. I usually use it inside of my function calls, but it actually makes no difference in terms of how.
Oh. Okay, that's good to know. Is that correct? Am I thinking the right thing?
Close. You're close. There's one thing that I'm going to change here.
Okay.
I think what we really need to do is we need to look at the model. So do me a favor. In the actual lab assignment,
Mm-hmm.
I think, where are we at? We are on step 4, correct? No, we're in the quadratic.
6.
We're on step 6. Okay. So the first thing we want to do is let's jot down what that second order model looks like. So let me switch screens real quick. If you don't mind to stop sharing, let's jot down what this is going to look like. And then that's going to help us see how we're going to enter this into R. So let me. All right. Can you see the Zoom whiteboard?
Yeah.
Perfect. All right. So what is our model going to look like? We know that X1, that's our heart rate.
Mm-hmm.
And we know that X2 is age. So we're going to fit the complete second order model. So let's first see what that looks like. I can move over there we go. So we're going to have the expected value of Y. Now I know the first thing I'm going to have is I'm going to have my intercept. We don't really care about that. And I know that I've got to have a term for each of my main effects.
Mm-hmm.
Okay. And I know also, oh, my eraser doesn't work in here. I also know that the other thing I'm going to need is the interaction between those two. So let's go ahead and add
Right. That. Okay.
We've got plus beta 3, x1, x2.
Mm-hmm.
And then since this is a complete second order, I'm also going to have those quadratic terms. So I'm going to have x1 squared and x2 squared. Do you agree with that?
Okay. Yes.
All right. Now, before we go back to R, let's draw on here. Let's see if I've got another color in here. Here we go. Let's separate this out into 2 pieces. Let's look at this piece, and let's look at this piece. All right. So this first piece, when we look at R, one way that we can code this piece is heart rate star age. So when we code that piece in R, what it's telling it is it's saying, all right, anytime I put the star, what it's telling is I want the interaction between heart rate and age, and I also want any lower terms. So in this case, my lower terms will be the X1 and the X2.
Okay.
But I also notice now we're missing these quadratic pieces.
Mm-hmm.
So there's no interaction here. These really are just tacking on these 2 variables that we have created. So here we're going to add on heart rate 2
and heart
and
Page 3.
age 2. So let me stop sharing here. Are you good for me to stop sharing? I should ask that first.
Yes. Yeah, no. Yeah, I'm good.
And so now I'll let you go back to your R code. That's what we're going to put into the R code.
That makes so much more sense. Okay, so then we want, let me just get rid of all that.
Oh, careful. We want a plus sign in between this because we don't want the interaction between the
These, yes.
And then one other thing, you're missing your response there at the beginning. So you want to have that systolic tilde.
I did not mean to erase that at the beginning and then totally forgot to put it back in. Okay, that makes sense because you're wanting the interaction between these two, but not the direct interaction.
Perfect.
Like,
and then I think you're going to get an error when you run this. And the reason is it's not going to know where systolic and heart rate and age are. You can try putting data, comma, data ICU inside the parentheses. Let's see if that, I think that's actually going to give you an error though.
Yeah.
So let's try it. So data equals, I think you named it ICU. Is that right?
ICU. ICU data, yeah.
Try that and see, but I think it's going to give you an error.
Okay.
Yeah. All right. So, so what we need to do is actually just up above that, since we've got some pieces that are part of the data set and some pieces that aren't. Oh, actually, I see what, actually, hold on, you're missing something else. In front of your parentheses systolic, you're missing the LM portion.
Oh, duh. Important detail to include.
So again, I think this is going to throw an error, but let's try it.
Okay.
Oh, nope, it didn't. Okay, so
No?
I think
So
that
then just...
so let's try the summary. That looks great.
Perfect. Okay, that makes so much more sense. Thank you for doing that step by step for me. That is made much more sense.
Anytime you all want to do that, I'm more than happy to.
Yeah, it makes sense when it's like, okay, this is what we like. I've taken in all my notes, and then sometimes I cannot figure out how they connect in the code. So thank you.
You're welcome.
That gives
Sorry
a really
for
good
everyone who had to listen.
You're fine. I love when other people have problems because I always learn things myself. Speaking of where we were talking about the assignment operator, which is the arrow assignment operator versus equals an assignment operator, that was a really good example of it because if you'd use the assignment operator for data equals ICU, data arrow, left arrow ICU, it would have created a whole new data set that was a duplicate of ICU named data and then set it as your data variable.
Yeah, that's a good point. So yeah, that's one of those few cases where it makes a difference. So for me, my general rule of thumb is if I'm creating an object, I use the arrow. But if I'm doing something inside of like the parentheses for a function, I use the equal sign. I don't know where I picked that up, but that seems fairly common that people do that. Like, so like if you go online and you look for help, I think most of the time that it's fairly common to see that, or people will default to all equal signs.
Is there an error in the code for the reduced model and the SAS?
Which step are you on?
Step 3, yeah. There's a line model burn rate equals break pow equals break pow rate. Is that a typo?
I'm looking here. And this is in the reduced model?
Yes.
No. Oh, okay, sorry. Tell me one more time where you think the error is.
Model burn rate equals break power rate, x2, x3.
Mine doesn't say that. Mine says burn rate equals fuel type brake power, unless I'm looking at the wrong thing.
It's under the comment fit reduced model. Proc red data equals diesel 2 model burn rate equals blah. It's the second to last comment.
Yes, that is a typo. That brake pow equals should be gone, I do believe. Yes, because the reduced model is just the main effects. Yes, that is a typo. So let me.
It should just be burn rate equals brake pow x2, x3.
That's exactly what it should be. Yep. Right. Or actually, hold on. No. That's just. Let me just fix that. That's wrong. There's some kind of copy and paste errors happen there. That line should be.
You realize, Dr. Ellis, this is doing nothing to make me like SAS anymore. It does. It's not your fault, but I just like. Again,
whichever one you learn first, or like type of language you learn first, that's always going to be the favorite, you know.
Like, because I just don't like the fact that SAS hides so much from you. Like the other day, like simple things like changing the titles of plots and whatnot, like, or like just kind of keeping track of variables. Like I can do all that in R much easier than this.
I think the big thing to remember that I have to remind myself of is that, and I already learned this lesson back when I worked with Fortran 77, is that like, since this was made to run on cards, like it's not made to be, SAS is supposed to be a language that you could write on a sheet of paper, hand to somebody, they could type it all in and then run it. And so like, it's not really something that's meant to be changed dynamically. And as somebody who likes dynamic languages, it can be really frustrating for me, but I try to remind myself of that. It's like dealing with old people. Like they're just old people. You can't do anything about it. Sometimes they're going to be racist and you just have to put up with it.
If I told you, just speaking off the cuff, if I told you half the shit that people have told me in clinic, you would be surprised.
Yeah, maybe. I don't know. I don't get surprised too easily with that stuff, but maybe. And also, Dr. Ellis, I have to disagree because the first language I learned was Java, and I fucking hate Java. Like I would rather write BASIC with only go-to statements, no loops, than I would write Java.
BASIC is actually a really good language.
I mean, for programming calculators.
Sorry, real quick. I replaced that PDF. So if somebody's looking for that correction, and so that is on the spot that I changed is on page 6, and it's under the fit reduced model. And that was the page you were on, correct? Was page 6? Okay. So that should be correct now. If you see anything else, let me know. Yeah, I think that was a copy paste error, which is weird that wasn't in my SAS code. But I'm sorry, continue.
Okay, just for the purposes to make sure that I understand all of this correctly, I know you're not asking for it or anything, but for step 7, where we're doing the fit third order model, is that possible to do with the ICU data? And in turn, would you just do the same thing that you did above, but to the third? Is that correct? Or is that not possible? And why would that be? Just so that I.
Sorry, let me go to, so I can make sure I get the verify.
Is this one of those to where it would be like kind of ridiculous, like not necessarily necessary, like how you talked about, to where you wouldn't necessarily use it for anything?
So if you wanted to do the third order model with 2 of them, what that would mean is you would need all third order terms. So a type of third order term that we haven't talked about would be, for example, the interaction between age squared and heart rate. So notice you can think of that as x1,
okay.
x2, x2.
Yeah.
So you would have to think of what all of those third order terms would be. And so we would do the same thing that we did before, where I would actually write out that model.
Yeah.
are there pieces I can clump together so it's easy to get the interaction from, and then the pieces that I need to tack on. So, but you could definitely do it, and it would be a very similar fashion. It would just be there's some extra terms that we would have to think about. So like I said, we would have age squared times heart rate would get added in. We would also get heart rate squared times age would get added in. And
That's it, right?
might be it. So you could actually do.
Some of the terms reduce then, right?
I don't think so, because you're gonna have heart rate, age, heart rate times age, heart rate squared times age squared
times heart rate.
So I don't think any of those are gonna
net cancel.
I must have missed something because I was thinking that you'd also have like heart rate, age, and surgical and medical service. I thought we were doing all three of them, each one up to second order, at which point, since, you know, X3 is binary.
Yeah, no, you're right in that case. So the X3, so that is different because those are actually second order terms. If you look at the interaction between the squared and the categorical, so the categorical doesn't count because it's binary, you're right. So that's actually a second order term.
But if you did it out in, at least in SAS, I think it's still going to count them. It's going to double count them, isn't it? Because it'll count both the unsquared and the squared version of the categorical term.
It does, but those are separate. So because what you'll have is you'll have age times the categorical. You'll also have age squared times the categorical. And actually in the third order model, you would have age cubed. That was what I'm forgetting. You also have age cubed and heart rate cubed.
Okay.
So you can do it, but it does get more complicated. But so what happens is the SAS output, what it will do is it will give estimates for each level of that categorical variable. So it will give estimates for each level of service compared to, for example, age squared, but one of those, it will be unestimable. So it will actually have like a 0 next to it. So when you get in these, I think you see that in some of the SAS output for this one, you're going to get all of it. But in the Proc GLM, what you're going to see is some of them are left blank. And it has to do with, it gives a row for each of the levels of the categorical variable. But remember that one of those is the dummy. So whichever one is the dummy isn't actually going to have the estimates next to it.
Okay. So is that like what Ankur was saying in his R output, where he had the NAs when he did it, when he expanded it mathematically instead of expanding it using just the star?
That was, if I'm not mistaken, and correct me if I'm wrong here, I think that was when there was another mistake in the code where we had systolic, where we had service instead of, we had systolic instead of service. So you were using Y to predict Y, is why that happened.
And I thought on that one, it didn't even run. It just kicked out the error saying that the predictor variable or the something variable was on the right-hand side. I thought it was after that was fixed that it ran and still had the NAs. But I could be wrong too. I mean, it's been a minute and we've been looking at other stuff.
I was trying to think. I can't remember. We'd have to go through and run it again because I was thinking once we expanded it, we got the same output either way. Manaza Ogechi, I feel like I haven't heard from you in a while. How's your code going? We stuck anywhere?
No, I mean, I got stuck in several places, but other people had those questions as well, so got those answers.
Same. Elizabeth asked most of the questions I had. I do have a question now. I'm trying to open SAS online. Oh, never mind. It came up. So does this thing sometimes where it won't let me open a new sheet, but it let me open it now, so I'm good. Thank you. I'll start it now.
I think you just have to ask the question and then it,
Yeah, basically.
Which version of SAS are you running? Are you on University Edition?
I am using the VirtualBox.
if you're running that one and then you open it in a web browser, right, to get
Yeah.
into the actual thing, my ad blocker was causing problems and it would cause weird issues like that. I had to disable the thing that I used to block ads.
Okay.
And that fixed it for me.
Okay, thank you.
What does the /solution do in SAS?
It gives you, it partitions everything out for those, it gives you all the, oh my goodness, the estimates for your prediction equation. So like if you, to see the difference, just take the solution off and rerun it and you'll see you don't get as much output basically. I don't know if this would apply to anyone, but if anyone works with mental health data at all, I just got an email about a student competition for a paper. It's a student paper competition that involves a methodological innovation or a novel application of statistical methods to a mental health issue. So if anybody's doing any kind of independent studies or anything that deal with mental health issues and you would like this email, just let me know.
I'm having a brain fart trying to do this the nested F test.
Mhm.
The ICU bit.
Is this this is the SAS one?
Yeah. One of those days.
Yeah, because this one's gonna be a little bit tricky because you'll have to create that new data set to use the proc reg. Yeah.
I'm basically just trying to repurpose the because we only have one there's only one categorical, right? So we only need one dummy variable.
That's exactly right. Well,
So,
there's one categorical variable with 2 levels. So yes, you only need one dummy.
yeah, so this goes.
Yep.
And then what is it? Age. And then what am I missing? It would be heart rate. No, because then you're gonna need 3 of these, right? Because then it's heart rate by rate x3.
Uh-huh.
So need x3, right? No, because that's redundant.
Well, X3 is your.
X3 is the recoded, is the dummy for the service.
So then don't you want heart
Age.
rate service and then you want age in service?
Age. X3.
So then you want age X3, right?
No, age X3, yeah.
And then you also want, if I remember right, is this the example? You also want the three-way interaction as well, right?
Well, this is for the F test, right? So.
But so this is because we're going to fit a full model and we're going to fit a reduced model.
Yeah.
The full model.
The full model and the reduced model are these up here, correct?
Yes, but remember you're going to refit those using proc reg so that you get the F test out of them. So to refit them in proc reg, you need that three-way interaction.
So then.
Yep.
All right. Apparently that works.
Mm-hmm. Yep. So now if you run this one, and then what I would do is I would compare, this output with the full model GLM, just to make sure you get the same thing. Hold on, something's wrong. Slow down for me. That's still for the GLM. I don't know if your screen's lagging or if it's SAS's being slow. So you want to scroll up to where you get the estimates. Yeah, there. Something's wrong, I think, with how you've got X3 defined. Let's go back and look at your code.
Is it case sensitive?
It shouldn't be. You can try it, but I don't think so. There's one wrong here.
It might be case sensitive, actually.
Yeah, try and see. Most of the time SAS is not, but I know, you know how it is. There's always a caveat. And actually what I'd like to do is after you run this, let's do a proc print of this ICU2 data set just to see what it looks like. And then if you scroll all the way over to the right, yeah, this should be our new. All right, so X3 is looking good now. So it may have been. So let's try rerunning that proc reg. There we go. That looks good.
Excellent.
Oh, one thing, actually, I just realized that it did. You might want to be careful here because when we ran the R code, I think if you compare your estimates with what you had before in the R code, I think you may have flipped your base case. I was trying to remember. Double check that those estimates are the same. It looked like, because I thought before the three-way interaction, the parameter estimate was like 0.0002, but I might be thinking of a different model. So just double check that those are the same.
It may be because I didn't re-level the factor.
I mean, it doesn't actually make a difference. It's just your output won't look exactly the same. It only makes a difference in the interpretation. Mine up. Oh no, I think that's right. That's what I had.
Well, in the F test though, what are the things? I'm just I cannot think right now. Like, what are the things that we're comparing though?
Yeah, so this is going to go back to if we look at our full model versus our reduced. And so to see this one, let me go back to, if you go to the actual lab page. So looking at the lab page, if we look at, let's see, this is for, you're on step, which step are you on?
This is step 4.
So on step 4, see how if we look at that full model and the reduced model, there's a difference of 4 parameters. Do you agree?
Yeah.
So those, all 4 of those parameters, those are what we're going to set equal to 0 in that nested statement. So for example, one of those is heart rate age. So we're going to have heart rate age, we're going to have heart rate service, age service, and then the three-way interaction. So one way to figure out is to actually just visually compare your 2 models. However many, whatever the number of parameters that differs between the 2, or you can think of like extra parameters the full model has, that's how many of those statements you're going to want to have in that line of code. Does that make sense?
On it. Again, my brain's literally just like scrambled eggs right now. So
yeah, I'm trying to remember for that one. I want to say it's like I'm actually not even going to guess. I'm not going to try to remember the number. Oh, actually, I've already made the key for that. Maybe I think you get. Have I done the key yet? Yeah, did you get, is the F you got like 1.25?
hold on. 1.03.
No, let me see your output. It could be rounding difference from where I did this one by hand. Oh, you can also compare it to the F test you got from your R output as well. Oh, scroll down for me. People go all the way to the bottom.
All the way at the bottom.
Yeah, go back to your SAS code for me. Okay. You are missing in your nested F test. think you're missing 1, 2, 3. By age. You're missing the heart rate service interaction. The heart no, you're missing the age service interaction. So you're missing
that's age X3.
yeah, but in the model statement. You see what I'm saying? You're missing one of your two-way interactions in your model statement. Yeah, try that now.
Yeah, that worked.
I checked what me and you were talking about just a minute ago, Amanda, and you are correct. It is the brain dead, the as factor systolic rather than as factor service that was causing the NAs in the output.
Oh, perfect. One thing before I forget, I really wanted to encourage you all, as you're working on this mini project, since you do have to write the code, make sure to reach out to me. If you're getting any errors, you're having any trouble with the code, I don't want you all spending, forever spinning your wheels on it. So feel free to send me the code if you get stuck anywhere. And you're allowed to use SAS or R. The choice is completely up to you.
SAS just needs to go away, please.
Except for you. You have to use SAS on your mini project too.
What? No, that's cruel and unusual punishment.
No, I don't want you to have a meltdown mid-semester. So
I got enough on my plate with all these interviews. Don't do this to me.
These are. Has everybody made it to the SAS portion?
Yes.
Awesome. Yes. And is your SAS working pretty good for you now, Getchy?
Yes, it's working out. Thank you. Perfect. I'm going to go ahead and log off now, though. See you guys.
Yeah. That sun that's blinding.
Seriously, though, I was like, oh my gosh. So I think I'm having the same issue that I had when I was running this in R, and I've already forgotten what I did or what is happening. So I don't have complete SAS pulled up, but I have my code put on a Google Doc. Can I share it and see where I'm at?
You're on. You're running SAS on one computer and then looking into another.
Yes. Not to make life any more difficult, of course. I didn't have the patience for the university edition. So I'm on step 4 for the SAS, obviously. Is that what step I'm on?
Yeah, that should, is that
Yeah.
here?
And so the values that I'm getting, I just don't feel like are matching up to what they were when I ran an R or anything.
I tried changing your reference to surgical.
Okay.
You may have had a different reference in the R.
Because I'm getting the F value at 1.93 and the P value at 0.1480, but that didn't sound right.
Let's see if I can find it. This one is for, you said step 4?
Yeah.
So this one is that 3-way interaction. So for this one, you get a 1.93? That doesn't
Yeah.
sound,
And when I did it in R, I had gotten 1.25 and 0.2915.
yes, that sounds right.
Oh, wait a minute. Hold on. I think I'm thinking ahead and haven't actually ran fully ahead yet.
Oh, gotcha.
That might be what it is, which is the story of my life. So let me try that and see if maybe I'm just getting too excited before I actually need to.
I was like, 'cause I don't see anything. Yeah, like I said, the only thing I could think of is change the reference over to surgical, but that shouldn't change.
Yeah. Okay, let me play around and maybe I just haven't gone far enough yet.
Yeah, let me know.
Okay.
Why does SAS hate me?
You're almost done. I know you're at the end, aren't you?
Nearly, but again, like when basically, yeah, almost. But like, okay, why didn't this work?
What error does it give you? It's because I think it's because you've got your work ICT. You see where it says view table work.icu2? It's because you've got the data set open there, I think. If you just close that out, like actually go down the bottom, yeah, open it and then actually like close it. Yeah, try that for all those and then see if it works.
And other idiosyncrasies of SAS.
Yeah, that's one of those things that always catch me. Or if you have it open in Excel, it won't run either. Go back to your code for me. Oh, I don't know. Sorry, I started thinking here.
Right, because for the second order model, you just need to square these things, right?
Yeah. But I'm blanking here. Sorry, hold on a second. Let me look at something.
I think the squared operator isn't a caret in SAS. I'm pretty sure it's a double asterisk.
I think you might be right. That's what I was just thinking.
I'm not quite there, so SAS might hate you, but I'm slower at it. Maybe it just needs somebody slow enough for it.
I think you are correct.
Yeah, that's what I was just. Yeah, it is. It's two asterisks.
I don't see it.
Should be all the way at the end, like to the right. Yeah, it's there because there's heart rate to age 2.
Okay, I was looking for something called like ICU. I was just like, wait, what? Thank you.
You all will be happy to know we are almost out of polynomial regression.
I like polynomial regression. The caret thing is because SAS is really old, and caret used to be, exclamation point used to be used for something else, and caret used to be used for like not equal and not and stuff.
It's like
But
bitwise operations or something ridiculous like that.
yeah, I don't remember what exclamation point was used for, but the times they were a-changing.
Oh yeah, and the other way that you can get, because I was like, what did I do in the code? The other way to get around that is instead of doing the square, you can just do age star age. So you'll actually see that when you get down to the last step, you'll notice when I do year to the third power, I did year times year times year. Did that work, Elizabeth?
I'm still working through it. My computer froze for a second, so it's old. It doesn't necessarily always work when it wants to.
So hold on, I'm sorry that so like in the model though, it's going to be systolic, age 2, heart rate 2, and then the interaction term between both of those squared terms. Or am I overthinking it?
Yeah, so there won't be the interaction between the two squared terms because that would be a fourth order term.
Okay.
So where this is a complete second order model, it's going to have
Just two.
Yeah.
Just age 2 and heart rate 2.
Yes, and then the interaction between them. So 5 terms total, is that right? Because you've got heart rate and you've got age. So you're going to have age, heart rate, age by heart rate squared, and age squared. So 5 terms. This is the one where we don't have service in there.
Wait, hold on. Oh, okay, I see.
So this is probably academic to what we do, because I don't think there's all that much floating point stuff in health. But if you just use the multiplier operator, it's slower than using a power operator like star or just the pow command. If you're doing anything with floating points, like significantly. But if you're doing stuff with integers, like we mostly seem to, they're identical, or if anything, multiplying is a little bit quicker because it doesn't have to check the function stack for different variables. Yeah, since these languages aren't statically typed, I don't think.
That makes sense. Yeah, I knew. That's one thing I'm bad about in terms of speed, because a lot of times, the stuff we're doing, especially like for class, we're not working with massive data sets, so it doesn't really matter. But I can imagine coming from where you've come from, I mean, that's got to be a huge concern, is speed, just because there's so much data.
Not really, honestly, because if you throw money at stuff, it disappears. So, and it's been 10, 12 years since I was doing university stuff. Industry, they don't care. Just buy more. At this point, you don't even have to buy more equipment. You just, the more money comes out of your Google, what is it? Google Cloud, GCM, I think, account. So.
Yeah, that's one thing I always pause, especially like with doing stuff like this. It's like, is it worth it to talk about speed? And then I'm like, nah, it'll be fine. Computers will be faster in a year from now, 2 years from now anyways.
Fit the quadratic model.
Okay, now I might have just overthought all of it. I went ahead and like worked my way through everything, and now I just might have overthought everything. So let me show what I have real quick. Well, let me find it first. Maybe that's a kicker. There we go. Oh. Okay. This is what I have. And I might have just gone way haywire and did not do any of this correctly.
It's being slow. Which step are you on, by the way?
I was on step 4.
Okay.
The creating all the new stuff, I think, really threw me for a loop.
Gotcha. So let's see what we got here. Okay, so there's the full model, the reduced model. Okay, so now we're gonna make our data set.
Mm-hmm.
Oh, okay. So remember that service is a single variable that has 2 levels. So we just only need one dummy variable for it. So there's not
Oh,
an x2 and an x3. It'll just be the x2. So you can actually just delete out the ifs. Yeah, let's get rid of that.
okay.
Okay, that looks good. Okay, so now we're going to have age by x2. So yes, now we can get rid of the age by x3.
And then the same thing for heart rate, right?
Exactly, exactly.
Okay.
And then there is one other term that you'll need, and that is going to be that 3-way interaction. So we need to do an age, heart rate, x2.
Gotcha. I'm just going to type this in here and then I can.
You know what I think? What another reason why I might really hate SAS? The lack of a dark mode.
Yeah.
Seriously, because staring at these white screens for hours on end just like fries your brain.
And then tell me if that doesn't work. And then you'll need to change, like down at the bottom, when you fit your full model, be careful. You'll also have to change that model statement.
Models. Okay, perfect. Yeah, let me try that. Okay, I knew that is probably where I had messed everything up was there. So let me see if that works.
No, I get you because I mean, it's an easy mistake to make because you're like, well, I've got service and I've got medical, but you got to remember those go together with one variable.
Yeah, shoot, every time.
So it surprises me how much stuff that's on the computer is white background. Like it's kind of the norm, but it's terrible for your eyes.
There was there used to be a Grease Monkey extension called it was like dark everywhere or something that it would basically try to force the CSS of a web page into a dark mode. It was kind of nice.
Yeah, I was gonna say, I always think it would look weird because I've gotten so used to most things having white background, but yeah, no, it's terrible for your eyes, or at least it seems like it's terrible. I know my eyes hurt.
Especially since I'm spending so much time in front of these computers now, like.
Oh yeah, especially.
Dark mode doesn't necessarily, but if you're on an OLED display, which most like modern phones and modern monitors and stuff are, then true black doesn't emit any light. And so true black and dark shades emit less light. And so they actually are better. I have that still installed on mine. I've got mine as a standalone too, so I can just click a little button in my bar and hit refresh. Like my Reddit right now is in its dark mode.
I cannot stand, sorry, this is my side rant. I don't know if it's because I always look at Reddit on my phone. I cannot stand looking at Reddit on my computer. Like the way that it's set up, like I like the app so much better.
See, and I'm like the reverse because I really don't like having separate apps for stuff. And every time I connect to it on my phone, I go in the web browser and it has that stupid pop-up at the bottom that's like, are you sure you want to continue in Firefox? Why don't you install the app? So I don't ever go to Reddit on my phone anymore.
Oh, so that's all every once in a while I'll get bored. I'll be like, oh, I'll pull up Reddit on my computer. And I last about 30 seconds and next thing I know my phone's in my hand because I don't know what it is. I can't stand it.
I think it's like what Ankur was saying about programming languages. It's, you know, it's what's familiar. We get used to it, and then anything new is jarring, especially as I get older. Like, I think part of it's the knowledge that I don't have the time to deal with learning new things all the time. And part of it's just, you know, I don't know, especially like all the Google platforms that I've seen die, like Google News and all that. Like when Google comes out with new things, I've even tried to learn Duo. I'm just like, it's not going to happen. You're going to replace it with, you know, Google Video Share, and then replace that with YouTube Blue or something. And I can't.
I have found I even do it in my everyday life. This is so stupid. I forget what it was. I came home one day and like my fiance had rearranged like the kitchen counter, like where all the, you know, the not utilities, where all the appliances were. And like I thought I was gonna have a mental meltdown. I was like, why is the toaster over here? What? Does it really make any difference? No. But it was like my brain was like, I can't. I need it in its spot. Or like bed. I can't. Yeah.
Well, so to your point, so like the brain is capable of operating without visual input, as we know, right? So it's the kind of thing where you could shut your eyes and quite literally walk through your house and do a reasonably good job at not bonking into things, because you know, just sort of like proprioceptively kind of where everything is in relation to your body and space. So yeah, I think that's what gets screwed with if you if you move something out of place. It's like, wait, this is not right.
Brain's like, this is not okay.
Or it's like the people who it's like the people who, like me, because I'm a bit of an ass, admittedly, who will like sit in a different seat in class just purposely to mess with people.
When I have undergraduates working groups, and this is like in a large class, that professor that like every couple weeks makes them switch groups and they hate it. There's a reason for it. Is if you stay in the same group, especially, again, this is mainly my intro students, those social dynamics take over. Whereas you have like the person that's working really hard, and you get the other person that figures out they can slack a little. Whereas if you make them switch up more, they're more uncomfortable with strangers, so they're less likely to kind of slack off, if that makes sense. Plus, it's good exposure to meet other people. Basically, I don't want them to ever get comfortable. I just want them to be uncomfortable all the time.
Well, and it solves a lot of student complaints, because, you know, if they're like, my group's not working hard enough, well, just wait another week. It'll be somebody else's problem.
Exactly. Elizabeth, did that work? Oh, you're muted.
No. Now I got this real weird F value that I've never seen before, so I really don't know what I'm doing.
Yeah. Over and look at it.
Let's take a look at it.
Let's see. Yep, I see what it is.
Okay.
So what we want to do, heart rate, age. Sorry, let me read these real quick.
No, you're fine.
So let's look at the fit full model first.
Okay.
So in our full model, we're going to have our three main effects, which are heart rate, age, and service, which is the X2. So you've got that.
Okay.
And then notice there's actually 3 two-way interactions. So you're going to have the we'll start with heart rate in X2, age in X2, but you've also got age and heart rate. So you're missing that two-way interaction.
So I need to get rid of.
Well, you're going to want that one in there too. So that's the 3-way.
Okay.
Oh, wait, did we miss one? Oh, we actually missed one up in your data set. Sorry about that. So notice in your data set, you're also missing the age and heart rate interaction.
Is that not what this one is? Sorry, I think I'm just confused.
Oh, no, you're good. So that one's a 3-way, because notice it's got 3 things that are multiplied by one another. So you've got age, heart, service.
Duh. Correct. Is that right?
Yep, and then you'll just want to do equals age times heart rate.
Okay.
Oh, I think you did the wrong character. You want age times heart rate.
Yes. Thank you for catching that. Okay.
Oh, and semicolon, not colon.
Oh.
It's late in the day. I get it.
Every time. Okay, let me try that now. That makes sense. when I started putting the X2s on everything, I just confuse myself more than I do anything else, it feels like. Okay. Make sure that looks good. Okay, so then now I need to add in that additional
Yes.
factor into the full model.
Exactly.
Okay.
And then your reduced model looks good.
Okay. And so then I'll just need to fix that on the nested F test, and then that should fix it.
Well, there's one other thing you gotta do with the nested
Okay.
F test, and then you're gonna be good. So
Okay.
have a look, actually go to the lab, the Word document, pull that up for me.
Mm-hmm.
All right, so if we look on, I don't even know what page we're on now, top of page 7. So notice there, we've got the comparison, we've got the full model,
Mm-hmm.
and then we've got the reduced model below it, right?
Mm-hmm. Yeah.
If we compare them, would you agree that there are 4 parameters in the full model that are not in the reduced?
Correct. Yes, I would agree.
So what we've got to do in that last line of that nested F test, we have to set each of those 4 equal to 0.
Okay. Okay. So the age, the heart rate, the H heart rate, the H heart rate service.
Exactly. So right now you've just got the heart rate service equal to 0, but we got to get all 4 of those equal to 0.
4 of those.
Yeah.
Okay. Okay. That totally makes sense. Okay. All right. Let me try that. I will update.
Oh no, what's SAS doing now?
Me?
Yeah.
No, I'm done. I'm just.
Okay. I thought SAS was. Yeah, okay.
No. This is
What's
me just
SAS doing now?
we're just trying to keep everything.
Do I need to?
Great.
Oh, sorry. Do I need to call out the test on each line, or as long as I don't put a semicolon, it will pull the right information?
Yep, you can just have it all on one line, so you can separate them out. I think.
Perfect.
And of course, I don't have the code up in front of me now. Where did it go? I've got so many things open. You do have to separate them by a comma, though. Have a look at the nested F test example. See how I've got break POW X2 and break POW X3? No, there is a comma in between, but you can have them all on the same line.
Shit. No, it's not. I have another interview tomorrow. I was just looking at the time they want me to, Zoom. It's not bad. It's 9:30 in the morning, but like, it's gonna be. I think it's gonna be another like, if not a half day, at least most of the day affair. So like, what they've tried to do is they've tried to sort of take the traditional interview day and essentially sort of adapt it to Zoom.
That's just rough. I mean, that's a long time to be on Zoom.
Yeah. It's one thing when you're like, when it's in person, they're like, they're like shutting you around. They're like, like essentially feeding and watering you, which is the fun part. Free food is always good. But.
And even that in between time, I mean, you kind of, so like, I remember when I did my interview for EKU, like in the middle of the day, we took a tour of campus, which, I mean, obviously you can't do via Zoom, but it was just nice because I got to be outside and like walk around.
Exactly.
And by the end of the day, I just remember being so exhausted just from talking to people constantly.
Yeah. And you keep on having to explain, like I've probably told the same story so many times.
And I remember who you've told what, and it's a lot. Like I need
to start writing thank you letters to people.
Yeah.
Yes, it finally worked.
Okay, good. I mean, that's a good thing though, because I mean, some people don't do that, and that really does it's something you're definitely supposed to do, but not everybody does.
Some programs actually, they specifically say don't send thank you letters.
Really?
So like everything in this process boils down to the rank list. So programs will make the rank list of candidates. I will make my rank list of programs, and then the match algorithm will take place. So they're very clear, like, oh, if you send us a thank you or not, it's not going to influence your rank. Some places like explicitly state that.
Interesting. I just think, obviously if they say they don't send one, I just think that's good life practice. I don't know. I'm real big on thank you notes.
Absolutely. But like, they like, because what happens is some people go overboard, and like in the past, some people have like, really overdone it. And
more
like
than
sending thank you Camaros.
Yeah. That's what I was thinking of.
Essentially graft. But like, I hate this process, and like, it's completely anti-competitive. So like, that's the thing. Like, it's not like if I wanted to, it's not like I can up and leave for another program that gives me a better offer, because there are no better offers. Like if you look at the U.S. code, there are legal exemptions for residency programs.
That's crazy.
Yeah, like residents are not allowed to unionize, even though they are like this. But like the like there's no like work hour protection. So like it's, the anti-competitive nature of the match has been sort of blessed and sanctified into U.S. law. So
residency, just in general, I have a friend that took a break from his just because it's rough. It is rough.
Honestly, this preventive medicine residency is pretty chill. I mean, like the hard part for us is just kind of getting back into the swing of like school, especially having to be like a full-time student and like also clinic and out rotation stuff. So like that gets a little bit hairy, but it beats 24-hour call. I'll tell you that. That is not a life that I would enjoy. Like the stories I've heard from just different residencies, I'm like, like what? Just like humor me for a moment.
Oh, I just know like my friend that and I can't remember what his residency was in. It was either internal medicine or emergency medicine. I can't remember now. He was out in rural, and like I said, he's like, I can't do it. Like it was like after a year or two, he was like, I have no social life. I have no support system. I'm just constantly on call. I'm constantly working. I'm miserable. He's like, this is just not worth it.
Well, honestly, like that's kind of what sort of happened to me, at least with where I was before coming here. Like every other day, 24-hour call, plus, I didn't know anybody in Jersey. So like, and like the other, like this being a very small program, like, the other residents at this program, it's not like they were sort of in a position because they all had their own like families.
Mm-hmm.
So it's not like we even had time to really like do anything as a group. Honestly, it's kind of the same problem that we have here, especially now, because like none of us residents have, really had a chance to like meet face to face this year. I mean, COVID being one thing, but like, it's another sort of concern. But having said that, like Dr. Johnson, Dr. Clang, they're very kind of cognizant of this, and they're doing, what they can to sort of ameliorate it, which is nice.
It really is such an important thing. It's by no means the same thing, but like when I was in graduate school, that camaraderie with other, basically it's misery loves company in some ways, but just to know, there are other people, it really does make a big difference. And not having that, it's just, I think it'd be incredibly difficult.
And it just sucks. Like, it's not like I have any incentive to leave this box.
Yeah.
But okay, enough doom and gloom.
I know it'll be over soon. I just keep on thinking after I get past, like I want to get past election season. You'll be past this. Just, you know, it's all gonna all be good. I can turn on the TV again. It's gonna be great. You'll be able to at least know where you're going next.
I'm actually starting to get like really, really scared just because like even like driving back and forth between like Lexington and Tennessee, like some of the stuff that we've been seeing on the roads is kind of scary.
Yeah, yeah. No, it's.
Yeah, Tennessee's like double truck fucked right now. It's insane going out to do grocery shopping and stuff down here.
Well, like, I mean, like, I'm just concerned, like, if, you know, if I'm wandering around by myself, if someone's going to say something to me.
Yeah.
Yeah. Yeah. One of my friends who's from Laos, her family's from Laos or whatever, I think. One of the Southeast Asians got a, you know, GTFO chink thrown at her. So, like a serious one, like leave this store.
I mean, it's amazing to me. It boggles my mind. Like I just can't even. I can't wrap my mind around it.
I mean, like, what? Do I start carrying something around as a just in case measure? No.
But I think it's a legitimate worry anymore. Like, you know, had you asked me 4 or 5 years, I mean, it's always been a worry, don't get me wrong. I mean, it's systemic racism has always been here. But I feel like somehow it's become almost okay. And I'm like, how has this happened? Like, this is not okay.
I saw a really neat article about how all the science denialism and the whole, you know, teach the controversy and, you know, other opinions are okay regardless of how terrible they are, is actually mostly, if you look at the people who are pushing this sort of stuff, it's the exact same people, the exact same groups who in the 90s were pushing the cigarettes are actually not that bad for you thing. And I know I sound like a loopy person when I say this, but I really think it's just capitalism here. We, you know, so much money is to be made off of all these things that, you know, it boils down and it gets pretty nasty. So I don't know. And as somebody, I used to be in charge of nonfiction when I managed at Barnes & Noble, and the history section was my favorite, history and bios. And my favorite history is all like between the war stuff, the interbellum in Europe. And like, this looks exactly like Nazi Germany or Prussia, like in between the wars. Like it's absurd to the point where it's scary. And me and my partner have talked about it, about staying, because we went out after I'm done with grad school, but we've talked about staying just because, like, you know, we're both white, we present cis and hetero, and so, like, you know, a lot of our friends don't have that sort of privilege, and so we've talked about staying just so, you know, like if our interracial friends who have a kid who can pass as white, you know, need the kid out, we can take them and travel with them and get them out.
It's crazy.
Which is messed up that we even have to talk about that shit.
Hey, Elizabeth, I want to check in. How's that quadratic stuff going?
Much better, I think. If I could have you confirm that I am doing this correctly, that would be great.
100%. I am ready. Okay.
I think I did it right, but I'm also not that confident with myself. Let's just be honest. So this is the first one. Your example was fine and it totally makes sense. And then this is what I have for the second one. Is this correct? I tried to mimic the same kind of thing where you were just timesing them.
You're so close. You're so close. The only thing you're missing is age and heart rate by itself, those lower order terms. You got all the higher order, you're just missing low order.
So like that instead. Okay. Okay. Perfect.
Looking good.
Every time.
Again, Zen.
Perfect, right?
What'd you say?
Practice makes perfect.
I need a lot of it.
I just keep on thinking like Zen of Python type stuff, because they say like explicit is better than implicit. So like yeah, even though you know, SAS and R are probably capable kind of doing lower order terms, or even just probably it just mentally makes more sense to write everything out. But okay, I guess as a sort of corollary to what Elizabeth was doing, can SAS automatically splay out the interactions like R can, or not so?
So, and this is where with this, it's syntax between the two. So in R, if we use the asterisk, it'll include the higher and the lower order terms. In SAS, that is just multiplying the two. In SAS, you do the same thing, except you use that vertical bar. That's why I got confused earlier I was trying to remember, wait, which one's the vertical bar? Is it SAS? Is it R? In SAS, if you do the vertical bar, and I think we did that, it was either this slide or the last one, there was one where you've got 3 terms in the example, hit that vertical bar, and that'll include all those lower order terms.
Okay.
Yeah, and it's just, again, the syntax between, I don't know why, but that syntax in particular always gets me because I'm always like, oh wait, which one is which?
The worst part is that a vertical bar is or in logic language. So it's like, come on.
Oh, I got kind of a nasty comment on one of my SAS database course homeworks because of that. I turned it in, and we're often supposed to say whether or not something's intuitive or what something is traditionally. I think I made the point, it might have been 675, but one of the questions was like, what is SQL historically used for? And my answer, I put a better part of it after, but my first part of my answer was just to start arguments with people that think it's pronounced SQL versus SQL and stuff like that. But I got an actual nasty comment back for putting that, because we were supposed to put why the pros and cons of the bar operator in SAS. And I put that it's not intuitive and that it's just terrible because of the fact that it's used for or and everything else, and it's used for almost a sort of and in SAS.
Well, I mean, I don't know. You could almost. I was gonna say you could almost, since cannot talk, since it's the inclusive or. So the inclusive or, when we think of like Venn diagrams, means it's in one, the other, or in both. So when we think of like how we include the terms, it could be the one by itself, the other by itself, or the interaction of the two. Maybe. Like I say, it mainly gets me because where SAS and R use the asterisk for different things. That's what gets me.
Okay, I think I have finished everything. I'm going to go back through everything now and make sure. But thank you so much for your help and for staying and helping me out in
So if you have
the detailed work.
And I really do mean it, guys, if you're working on that mini project and you get stuck, please email me. I'm more than happy to help with that.
Okay, perfect. Thank you so much. I appreciate your patience. Thanks, you do.
All right, are we all heading off?
I think so. Real quick before you do though, that's what the exclamation point used to be used for apparently, and it still is in SAS. You can use exclamation point as or in SAS.
Wait,
so that's
what?
why, yeah, and so caret is not, exclamation point is or,
stop.
and double asterisk is power. It's why operators get so confused. I still use like POW parentheses, 2,3 for 2 to the third, because operators.
The exclamation point is a negation operator, period. Full stop.
Yeah. Thank you, SAS.
All right, you all. Have a great day. I'll see you next week.
Oh, actually, one last thing before. I only need one of you two, so if one will stay on, and actually only take a second. Can you tell me if you can see my screen flash or something when I do this? I've got 2 things. Did anybody see that?
A little bit, just on your face. Like it looked like the light changed.
Okay, and what about this? There.
Oh, that was more pronounced. Like that looked almost like
the second one was worse.
Yeah.
Okay, they're visual bells for like when I backspace everything out in terminal is the first one, and then if I hit a runtime error in a program seg faults, the second one throws whenever there's a whenever something ends with a not a status of 0, the second one throws. Because I like visual bells because my computer is usually on mute, but I just realized earlier that I thought they might be visible on here, so thank you for that.
Yeah.
I wonder what people think then, because I'm often working on code while sitting in random Zoom meetings that don't have anything to do with coding, and so my screen flashing like that must be kind of weird.
Yeah, the first one, like if I wasn't looking for anything on the first one, I wouldn't have
Yeah.
noticed. The second
That
one
one.
was pretty noticeable.
Yeah.
All
Yeah,
right.
the second one is.
Cool. Have a good night.
Bye.
We'll see you all. Have a good night.
Oh.